Well, today I'm going to show you what is additive manufacturing and 3D printing. Are 3D printing and additive manufacturing the same thing? Generally, we know that terms stretch over time to include more than just their default meanings. Whatever the name, new ways of fabricating directly from byte to stuff are radically changing the what, where, how, and when of making objects. What roles then do the two terms additive manufacturing and 3D printing play in describing new ways of making? Additive manufacturing uses data computer-aided design softwares or 3D objects scanners to direct hardware to deposit materials layer upon layer in precise geometric shapes. As the name implies, additive manufacturing adds material to create an object. By contrast, when you create an object by traditional means, that means subtracting manufacturing, it is often necessary to remove materials from milling, machining, carving, shaping, or other means. Additive manufacturing or additive layer manufacturing is the industrial production name for 3D printing, a computer-controlled process that creates 3D dimensional objects by depositing materials, usually layers. When MIT invented binder jet printing in the 1980s, they wrote, "Three-dimensional printing is a process under development at MIT for the rapid and flexible production of prototype parts, end-user parts, and tools directly from CAD models." Additive manufacturing was first used to develop prototypes in the 1980s. These objects were not usually functional. This process known as rapid prototyping because it allowed people to create scale models of final objects quickly without the typical setup process and cost involved in creating a prototype. As additive manufacturing improved, its uses expand to rapid, which was used to create mold for final product. But by the year 2000, additive manufacturing was being used to create functional products. More recently, companies like Boeing and General Electric have begun using additive manufacturing as an integral part of their business process. Today, our concept of 3D printing is much broader, but the term is often associated with the filament-based plastic printers, which are the pride and the joy of many hobbyists and self-described makers. But there are also binder jet printers, laser meters, 3D printers, as well as glass and clay 3D printers. Additive manufacturing versus subtractive manufacturing. Additive is the adjective. Additive means tending to or able to add. If a process is additive, it means that it is adding things. The adjective subtractive, on the other hand, means tending to or able to remove or subtract. A subtractive process is one that is removing or taking away things. Subtractive manufacturing is the traditional way of making things. You start with a large block of something and gradually cut away bits of it until you have the desired object. We also call this process machining. Machining involves hollowing, cutting, or taking part out of a block of something. It could be a block of, or for example, stick or material. Additive manufacturing means creating 3D objects by starting with nothing, adding one superfine layer at a time. 3D printing is one type of additive manufacturing. Over the past few decades, additive manufacturing technology has advanced considerably. As 3D printers today, for example, can create jet engine turbines, spare parts for vehicles, and even whole houses. Additive manufacturing 7 categories we will see in the next slide. Why is additive manufacturing important? Additive manufacturing is important for the creation of lighter, complex design that may be too difficult or expensive to produce using traditional manufacturing techniques. Removing the needs for molds, milling, and machining, additive manufacturing offers a range of advantages for both prototyping and production. What is a transformation? It may be something of stretch to say that additive manufacturing will change the world, but it is already having a positive impact. It allows for the creation of complex design with less materials wastage when comparing to parts that require machining, as well as allowing for the creation of lighter structures. When these lighter structures are applied to aerospace or automotive applications, for example, they lead to fuel saving and related environmental and financial benefits. Manufacturing also for the replacement of parts otherwise be impossible to replace, meaning that machines can be repaired rather than scrapped. In addition to this benefit, additive manufacturing has also seen a level of democratizations on manufacturing as more people set up domestic 3D printing stations to produce their own bespoke items. Additive manufacturing changes the way we think about the supply chains, taking part from the point of manufacturing to the point of use. Additive manufacturing is flexible in the time it takes to load a file from anywhere in the world. It enables customized parts in volume and involves stocking raw materials like filament and printing part on demand. Additive manufacturing technologies. Additive manufacturing technologies can be broadly divided into 3 types. The first of which is sintering, whereby the material is heated without being liquefied to create complex high-resolution objects. Direct material laser sintering uses metal powder, whereas selective laser sintering using a laser on thermoplastic powder so that the particles stick together. The second additive manufacturing technology fully melts the materials. This includes direct laser metals sintering, which use a laser to melt layers of metals powder, and electron beam melting, which use electron beam to melt the powders. The third broad type of technology is stereolithography, which uses a process called photopolymerization, whereby an ultraviolet laser is fired into a vat of photopolymer resin to create turkey resistance ceramic parts able to endure extreme temperatures. How does additive manufacturing works? Using computer design or 3D object scanners, additive manufacturing allows for the creation of objects with precise geometric shapes These are built layer by layer as with 3D printing process, which is contrast to traditional manufacturing that often requires machining or other technique to remove surplus materials. Additive manufacturing process. Additive manufacturing process has 7 categories. There are a number of distinct additive manufacturing process with their own standard, which includes binder jetting. This technique uses a 3D printing style head moving on X, Y, and Z axis to deposit alternating layers of powdered materials and liquid binders as an adhesive. Second, directed energy deposition. Directed energy deposition additive manufacturing can be used with a wide variety of materials, including ceramics, metals, and polymer. A laser, electric arc, or an electric beam gun mounted on arm moves horizontally, melting wire, filament, feedstock, or powder to build up materials as a bead move vertically. Third, material extrusion. This common additive manufacturing process uses spooled polymers which are either extruded or drawn through a heated nozzle which is mounted on movable arm. This builds melted materials layer by layer as the nozzle moves horizontally and the bed moves vertically. The layers adhere through temperature or chemical bonding agent. 4. Powder bed fusion. Powder bed fusion encompasses a variety of additive manufacturing techniques, including direct metal laser melting, direct metal laser sintering, electron beam melting, selective laser sintering, and selective heat sintering. Electronic beam laser or thermal print heads are used to melt or partially melt fine layers of materials, after which excess powder is blasted away. 5. Sheet lamination. Sheet lamination can be split into 2 technologies: laminated object manufacturing and ultrasonic additive manufacturing. Laminated object manufacturing is suited to creating items with visual or aesthetic appeal and uses alternative layers of paper and adhesive. Additive manufacturing ultrasonic uses ultrasonic welding to join thin metal sheets, a lower energy, a lower temperatures process. Ultrasonic manufacturing can be used with various metals such as aluminum, stainless steel, and titanium. 6. Vat polymerization. This process uses vat of liquid resin photopolymer to create an object layer by layer. Mirror are used to direct ultraviolet light which cures the successive layers of resin through photopolymerization. 7. Material jetting. Wire additive manufacturing uses arc welding power source and manipulators to build 3D shapes through arc deposits. This process commonly uses wire as material source and follows predetermined paths to create the desired shape. This method of additive manufacturing is usually performed using robotic welding equipment. What materials can be used in additive manufacturing? There are a variety of materials used for additive manufacturing. These include biochemical ceramic. Biochemicals used in additive manufacturing include silicon, calcium, phosphate, and zinc, while bio-ink fabricated from stem cells are also being explored. These materials are generally used for healthcare applications. Ceramics. A range of ceramics are used in additive manufacturing, including aluminum, calcium, phosphate, zirconia, as well as powdered glass, which can be packed together with adhesive to create new types of glass products. Metals. A wide variety of metals and metals alloy are used for additive manufacturing, including gold and silver, stainless steel, and titanium, amongst others. These can be made to create a variety of different metal parts, ranging from jewelry to aerospace components. Thermoplastic. The thermoplastic polymers are the most commonly used of additive manufacturing materials and include a variety of types with their own advantage and applications. These include acrylonitrile, butadiene, serine, polytic acid, and polycarbonate, as well as water-soluble polyvinyl alcohol, which can provide temporary support before being dissolved. Where is additive manufacturing used? Aerospace. Additive manufacturing particularly suited to aerospace application due to its weight-saving capability and ability to produce complex geometric parts such as belasks. Automotive. A variety of materials are widely additive manufacturing for automotive industry as they rapidly prototyped while offering weight and cost reductions. Medical. The medical sector is finding an increasing number of applications for additive manufactured parts, especially for bespoke custom-fitted implants and devices. Advantage, or what are some benefits of additive manufacturing? Number one is complex geometries. The technology enables engineers to design parts that incorporate complexity that is not possible using other methods. Intricate features such as conformed cooling passages can be incorporated directly into design. Parts that previously required assembly and welding or brazing of multiple pieces can now be grown as single part, which makes for greater strength and durability. Designers are no longer restricted to the limitation of traditional machines and can create parts with great design of freedom. The second benefit or advantage of additive manufacturing is time saving. Additive manufacturing is ideal for getting prototype made quickly. Parts are manufactured directly from 3D CAD files, which eliminates the cost and the lengthy process of having fixture or dies created. Plus, changes can be made midstream with virtual no interruption in the process. Weight savings. By incorporating organic structure into design, designers can eliminate substantial weight while maintaining the part strength and integrity. An illustration of this advantage can be seen in Garba bracket challenge conducted by G. An existing bracket was designed for additive manufacturing with the winning entry maintaining strength of the original while reducing the weight by 84%. This is all additive manufacturing and 3D printing. Thank you.